Okay, so we will continue the summation identities for trig. And so we already talked about the summation identity for sine, so naturally the next thing to talk about is the summation identity for cosine. So now we want, okay, cosine of alpha plus beta. Is there some way to express this in terms of just cosine of alphas and betas and sines of alphas and betas? And of course there is. So let's go through this process again and see how I do that. So, there's the same triangle. Let's label the hypotenuse as some length. And now, if we want to say, okay, what is the ratio of cosine, right? The ratio of the adjacent to the hypotenuse when we add two angles together, alpha plus beta. Well, okay, again, this is not a right angle. So first thing to do is we only know sines and cosines, and we only know right triangles. So let's just extend this over until it becomes a right angle here. Okay? And then remember, what I said before is that these two angles are complementary, or this is going to be 90 degrees minus alpha, right? So this is 90 degree minus alpha, and this means it's going to be alpha. So this is going to measure alpha. And now, okay, let's drop this line here. Okay, so the end goal, and this is the right triangle, of course, with the straight line. So the question is really, what is the length of this side, from the vertex of the triangle to here. Okay, but so before we find that, let's find the length of the longer side and then subtract out this extra part. Okay, so what is the length from here all the way to here? Well, again, as we said, is that here this is the hypotenuse, and now we want to get the adjacent side in this right triangle. So that means the length from here to here is going to be c times the cosine of beta. Okay, so this is the rule in general, is that if you have a hypotenuse and you have an angle, and then you want to get an expression for the adjacent side, it's going to be hypotenuse times cosine of the angle. Okay? Similarly, for this opposite side here, we will do the hypotenuse times the sine of beta. So before I went through the steps, this said okay, opposite is going to be this thing divided by that, and then that's equal to sine of beta, and we can multiply to the other side, and we get c sine of beta. But now, now that we sort of understand the concepts, then we can directly, directly just say, okay, we want the opposite side, or we want the adjacent side. It's going to be hypotenuse times cosine of the angle. If we want the opposite side, it's going to be the hypotenuse times the sine of the angle. So it's, once we know the rule, then we can just directly apply it, and it should be true. If you want, you can also write out all the steps where you say, okay, this length is going to be d, and then d divided by c is going to be the sine of beta, because opposite over hypotenuse. So d is equal to c sine of beta. See, we get the same thing. So it's better just to remember. Want the opposite side, multiply hypotenuse by sine of beta. Want the adjacent side, multiply hypotenuse by cosine of beta. Okay. Well, now here, this is the hypotenuse of this right triangle. Again, remember the rule is, we know the hypotenuse, we want to get the adjacent side. So we multiply the hypotenuse by the cosine of this angle. So the hypotenuse was c cosine of beta. I want to multiply by cosine of this angle. So we multiply it again by cosine of alpha. And this gives us the distance from here to here. So again, triangle, get this length, and then get this length from it by multiplying cosine beta, multiply cosine alpha, right? Adjacent to that one, and the adjacent to that one. So two right triangles, adjacent, adjacent. Okay, so now we have the length from here to here, but now we need to subtract out this missing length, right? Well, it turns out, is this missing length hard to find? No, it's actually quite simple. This length here is going to be exactly the same as this length here, right? And here it's because it's parallel lines, and we just transfer it up. So we need to find the distance from here to here, and this is a right triangle. So here this is the hypotenuse, and this is the opposite side to this angle with the hypotenuse. Remember, we want to find the length of the opposite side, take the hypotenuse, multiply it by the sine of this angle. So this is going to give us c sine of beta, the hypotenuse length, times the sine of the angle. is going to give us the length of the opposite side. And so now, so these actually give us, so this is the total length. So C cosine beta cosine alpha gives me this entire length here. And this length, C sine beta sine alpha, is going to give me this length here. So what does that mean is that, well, to find the length here, we just take this total length and subtract out this smaller length. So, okay, cosine of alpha plus beta is going to be this side length divided by C. This side was this minus this, right? So the long line minus the length of this shorter line segment here. Right? So remember C cosine, C sine beta sine alpha. And you're going to divide it by the length of the hypotenuse. So this length, by taking this thing, subtracting this thing, we get this length, and divide by the hypotenuse, C. Now that gives us an expression where the C is going to cancel, so this is going to give us cosine beta cosine alpha minus sine beta sine alpha. And normally in trig, they reorganize it so the alphas and betas come first, and so on. So this one is going to become cosine alpha cosine beta, because it's cosine beta times cosine alpha, so you can switch the order in which we multiply them around, and minus sine alpha sine beta, switch the orders in which we multiply these signs around. And this is the identity for the cosine of two angles added together. So cosine of alpha plus b is cosine alpha times cosine b beta minus sine alpha times sine beta. So again, this is another formula that's pretty easy to remember, and once you know it and know why it's true, then it's better just to remember this formula and to use it whenever you need to compute the cosine of the sums of two different angles. And so this is another trig identity for summation.